Hello students, when I say the word cylinder, what pops up in your mind? A common man might think of an LPG cylinder like this, but since you are a student of mathematics, you would imagine a shape something like this. We are in fact surrounded by a number of objects that are cylindrical in shape. If you enter the kitchen in your house, you will find that many utensils are actually cylindrical in shape. If you go outside, the stems of trees are also cylindrical. Be it the pillars of massive structures like this, or the pipelines that supply water to our houses, or even the pen with which we write, all of them have some cylindrical elements in them. Since cylinders are important parts of our lives, it's very important for us to study the geometry of cylinder. A cylinder has two flat surfaces, one at the top, another at the bottom. The bottom flat surface is called the base of the cylinder. In fact, both these flat surfaces are circular in shape. In between the top surface and the bottom surface, there is a curved surface in the cylinder. An imaginary line that joins the centers of the two circles is called as the axis of the cylinder. Cylinders are classified into a number of types. Broadly, we can categorize cylinders into right circular cylinders and oblique cylinders. In right circular cylinder, the axis of the cylinder is perpendicular to the base. The angle made by the axis to the base is 90 degrees. Whereas in an oblique cylinder, the angle is not 90 degrees. The axis is slightly bent over. Another way of classifying cylinders is solid cylinders and hollow cylinders. This is a solid cylinder. This is a hollow cylinder. A solid cylinder is completely filled with material, whereas a hollow cylinder has a through hole in between. In geometry, to define any cylinder, we use two measurements. One is the radius of the base. The second one is the height of the cylinder. Just to give you an idea, we'll take an example. A right cylinder with base radius 6 centimeters and height 20 centimeters would look something like this. For any three-dimensional shape, we try to find out the surface area as well as volume. Surface area is the sum of areas of all the faces in the shape. You might get the question in your mind, why should we calculate the surface area? Or what is the actual use of calculating the surface area? Let me just explain that using an example. Let's say you have to paint this cylindrical structure over here. If you have to estimate the quantity of paint required and cost of the required paint, you will have to calculate the surface area of that cylindrical structure. Let us now find out the curved surface area of the cylinder. To do that, let us take this rolled sheet of paper as the curved surface of the cylinder. If you slowly unroll this sheet of paper, you will find that this is actually a rectangle. Now, if I somehow find out the area of this rectangle, we get the curved surface area of the cylinder. If you observe carefully, the circumference of this circle is actually the length of this rectangle. If r is the radius of the circle, 2 pi r will be the circumference, that is length of the rectangle. The breadth of the rectangle is nothing but the height of the cylinder is h. We know that the area of any rectangle is length into breadth. So this becomes 2 pi r, which is the length, to height, which is the. So the curved surface area of a cylinder is 2 pi r. Now we shall try to find out the total surface area of the cylinder. The total surface area is the area of the curved surface plus area of the top circle and the area of the bottom circle. So the total surface area will be curved surface area plus area of two circles. We know that the curved surface area is 2 pi rh. Area of the top circle will be pi r square. Area of the base or the bottom circle will be pi r square. This becomes 2 pi rh plus 2 pi r square. But take 2 pi and r common, we get 2 pi r into r plus h. This is nothing but the total surface area of a cylinder. Now let us find out the volume of the cylinder. What do you mean by the term volume? Volume actually means the space occupied by the object or the 3D shape. To give a feel of what volume is, if we have to find out what is the quantity of water that has been stored in this tank, we should know the volume of this. To find the volume of a cylinder, we will use the example of a cuboid. To find the volume of a cuboid, we first found out the area of the base. The area of the base is L into B. For that, we multiplied the height. So the volume of the cuboid becomes L into B into H. Similarly, for a cylinder, to find out the volume, we'll first find out the area of the base. Here the area of the base is pi r square and multiply it by the height. So the volume of the cylinder becomes pi r square h. To summarize all the three formulae that we have studied today, in a cylinder, the curved surface area is given by 2 pi r. The total surface area is given by 2 pi r into r plus h. Finally, volume of the cylinder is pi r square h. Let us now take a simple problem to understand the concept better. The problem says the curved surface area of a right circular cylinder of height 14 centimeters is 88 square centimeters. Find the diameter of the base of the cylinder. Let us just write what is given in the problem. The height of the cylinder is given as 14 centimeters. The curved surface area is 88 centimeters square. We have to find out the diameter of. For that, we will use the curved surface area formula. Curved surface area is given by 2 pi rh. This implies 88 is equal to 2 into the value of pi is 22 by 7. Radius is unknown. The height is 14 centimeters. If you cancel 7 and 14, you get 2 into 22 into 2 in the numerator. So that becomes 88 is equal to 88 into r. So we get the radius as 88 by 88, which is 1 centimeter. If the radius is 1 centimeter, diameter will be 2r, which is 2 centimeter. Hence 2 centimeter